Thank you for joining us for Spa Parts Plus troubleshooting video guides. Whether you're a novice or an experienced repair person, we hope that you'll benefit from this program in our series. And now, here's Tim.
In this video, we're going to cover the air injection system. It uses a separate motor called a blower. The concept here is to create a flow of tiny little bubbles that creates an even massage. So let's go into the shop. We'll take a closer look at this system. The air blower provides therapy by forcing air into the spa through injectors or holes under the seat. Some spas use the airflow to complement the massaging action of the water by directing it into the water jets. This is called turbocharging. Most air blowers used in spas today are flow-through motors. The motor is cooled by air passing through it on its way to the spa. Some air blowers use motors which keep the air going into the spa separate from the air cooling the motor. The advantage of using this type of motor is that the running temperature of the motor is independent of the amount of air passing through the main impellers. These motors are known as the radial bypass motors and tangential bypass motor. The air is moved through the system by a simple motor fitted with an impeller. Air is pulled from around the motor and discharged through the outlet of the blower housing. It's critical that the air release system be properly sized for the motor. Now, to determine this, you must first of all consider the size of the motor itself. In addition, you must also consider the number of holes and jets, plus their size, and the length of the plumbing run. Now, if the system is not properly sized, the motor could overheat, the bubbles could be inadequate or poorly distributed. We'll be using this troubleshooting flow chart to take a look at the system. For the sake of this demonstration, we're going to assume that we don't have any bubbles in the spa. The first thing we're going to want to do is to take a look at our blower motor and see if it's running. Obviously, in this case, it is not. So what we're going to do is check the voltage using our multimeter at the motor. Get this on here. And you can see that we do not have the proper voltage. So let's check the voltage at our source. And once again, we do not have the proper voltage, so we must have a bad source switch. If the blower is running, but we still have no air pumping into the tub, we have a problem with the air distribution system. Either the plumbing is not secure or the anti-backflow device has failed. The extent of servicing these motors should be limited to replacing worn-down brushes or replacing the motor itself. These motors should never be disassembled or serviced in any other way. Well, now that we've finished with this demonstration, let's head out into the field, and we're going to service a real blower. We're on location again with our technician, Doug. And Doug, what's the situation with this spa?
Well, Tim, our customer's complaining that they're not getting any action from the air bubbler when they push the buttons for it. As I approached the job, I checked the main panel, found out that the breaker is on, so we should have power supplied to the unit. I'm going to come up. This is the button for the blower. As you see, I'm pushing it, and we don't have any action at all.
Okay.
So next thing I'm going to do is I'm going to get into the control system and see if we have voltage going there. If we have voltage but no action, we'll have to trace it through the system and see where our voltage is into that. Now, unlike a mechanical system, this one, from experience I can tell, has a circuit board in it. So basically what I'm looking for here is the circuit for the blower. I can do that by following the blower cord and following the hot wire right to this position. So what we're going to do is we're going to take our voltage tester, turn our meter on to volts. We're going to get a neutral off of the load side of our GFI. Here we are. Okay. And I'm going to take my other probe and go right into the blower pin. Now, checking to see that I am in the on position, I see we have voltage going out to the blower, but again, as we can tell, there's no action. So what this has told me right here is I have voltage to the system. We have voltage that should be supplied to the blower motor, but with no action, most likely we have a bad motor. But I do have one other connection at the blower, so I'm going to make sure that that hasn't come apart before replacing the motor.
Important to check that before you go to the trouble of doing that.
Sure, I could be putting the motor in and there really be nothing wrong with it with just a loose connection at that end.
Okay, let's go ahead and do that.
You bet that'll take me just a moment. Okay, Tim, I've removed the motor from the blower pipe, and I've gone ahead and removed the cover for the junction box. This is where our main wire coming in meets the blower motor wires. What I'm going to do is take my voltage tester, stick it in the hot, and the cap for the neutral. And with my power still coming to it and the switch still on, we do have voltage to this. So what it is telling me is that we do have a bad motor. We're going to have to take it apart, replace it, and I'd like to show you how we do that. But first I'm going to go shut off the power to make sure everything's safe.
Good move.
You bet. Okay, Tim, I'm back from turning the power off. What we're going to do is we first need to take the housing apart to expose the motor. We have 2 screws here. One and 2. Now we can also safely undo our wires.
Okay. And at this point in time, we'd find out in a real hurry if you had forgotten to shut the power off or
Yeah,
got the
we
wrong
would.
breaker, right?
Yeah, we would.
Okay. All right, so you've removed the wire nuts.
Move the wires. Pull the motor out. I'll tell you one of the major things that happens with these most of the time, and I can pretty well see by this one also, the spa is not built with a proper Hartford loop in it. Now what a Hartford loop does is takes the water and air up to a certain point where the water won't go over this loop to get into the motor. We're not to have any water in this motor whatsoever. If water gets over the loop or they put a check valve in there and that check valve fails, it'll flood the motor out and that'll be your worst damage. So often if you see a blower that's had water damage, now this one's had some, but I'm going to tell you this is mostly just moisture damage rather than flooded out by water.
Are you referring to like condensation or?
Yeah, this one's got mostly condensation damage. If I had opened this up and water just came pouring out, I'd want to reconstruct that loop, put a new check valve in there. Otherwise, I'm probably going to be back here within the next month or so doing it again right the second time.
Right.
But my determination here has been just that that's just condensation, and our real problem is just an old motor. This spot here is probably about 8 years old. One last screw. Of course, there's always one that's going to give you a hard time.
Yeah, always. Now with a new spa motor in here, you won't have to worry about the condensation problem for some time to come, right?
Probably not for several years. We'll take our new motor that has our gasket and that on it, take our housing, put it back over it, and secure it to our housing with the 4 bolts.
All right.
Okay. Now the secret here is we got to make sure this is tight so we don't have air blowing by. We'll set it back into our housing, feeding our wires in. Thank you, Tim.
Sure.
Go ahead and let me turn that like that.
Okay.
Actually, this is one of the easier housings to get into. Some housings are pressed metal onto it. Those can be difficult to get onto. A little perseverance, you can do it. Some housings, if they're metal and they become too water damaged, probably best changing the whole blower. You're really doing your customer a lot better if you can replace the motor than the whole blower, unless they want to go into a new Super Silent series, which is a totally differently designed housing. But anyways, this is our blower back together. We'll be reinstalling it. We'll do one final test to make sure it's okay, and then we'll be able to go on from there.
Sounds good.
Okay, Tim, we put the blower motor back into the housing. We put the housing back onto the plumbing, and now for the final test.
All right, push the button.
You bet.
All right, good job.
Well, that should do it, Tim.
Good enough.